Hey guys, Mrs. Brislin. All right, so video 2, we're on primary gross and net productivity. So I do have a video for that I'd like you to check out. It is this one. It is another teacher that's doing a quick little lecture. It's not the best video quality, but ocean productivity, light dark bottle method. And it's by Professor Sean Chamberlain. So he does a really good job of explaining. He's even using the same pictures that we use on the next slide. So I'm moving myself around here, so I'm not covering up the words, but primary production is the rate of energy. Rate energy is converted by photosynthetic and chemosynthetic autotrophs to organic substances. We often like to look at the gross production. That's the total amount of chemical energy as biomass created in a given length of time. So we talked about how important it is to be studying productivity, so we know and want to make or are certain that our oceans are healthy. So net production is the gross production minus the respiration. So we're really looking at production. We're looking at oxygen. We can measure oxygen, and we'll talk about that in the next slide here with the bottles. So the energy available to higher trophic levels measured in kilojoules, so calories there. So that's looking at energy. And I think you kind of can get the idea by looking at the images here. You can stop at what we're looking at here. So NPP equals GPP minus R, and we can even look at we'll go into this and just actually watch the video on the next slide. But a really nice way to measure that, and it's something we do often, and it's called the light dark bottle method. Kind of looks like this. This is really illustrated. We have more machinery and kind of a little more tech material, but you can do this in an aquarium. So you take a dark bottle versus a light bottle and have similar organisms, phytoplankton, and then you look to see how much oxygen is being produced. Remember, one bottle will always have respiration going on, but also if it's a light bottle, sun's going to penetrate and you'll see oxygen production, so photosynthesis. Whereas a dark bottle, all you're going to have there is respiration. And so that gives us the data, the numbers. By looking at the dissolved oxygen, we can determine how productive these water columns are. So we can go down in depth and see where is that compensation depth. So where are they equal? Where is the most prosperous phytoplankton or productive area of the water? Okay. So we talked about there's lots of other factors that can limit this, but definitely the amount of light will be a factor. So light dark bottle method that result in release of oxygen gas, and this oxygen gas dissolves in water, and dissolved oxygen contain increase equal to our carbon dioxide absorption, dissolved oxygen light. So this is the formula, minus the dissolved oxygen dark bottle. That'll equal your net primary productivity. And then again, looking at respiration, we can take our the initial, so dissolved oxygen initial bottle, minus our dissolved oxygen dark bottle, and that would give us and then our next formula, we can also, we're just kind of moving around these variables. So our gross would be our net primary productivity plus our respiration. So watch the video. I'm sorry I'm rushing, but I know these videos, I'm limited in time, so I'm trying to cram it in and not have a bunch of videos. So other methods are carbon dioxide consumption. So looking at chlorophyll method captures chlorophyll amounts in water and shows energy transfer from phytoplankton through productivity. That's another process. And then also looking at straight biomass, and that is harvest method in unit area by uprooting phytoplankton, and they're filtered taking unit volume or by with filtration. So what is the most accurate? Our dark light bottle, it will be our most accurate process. Okay. All right. Looks like I'm reaching my limitations here. Marine environment. Remember, light, temperature. So these are our limiting factors. Light, temperature, nutrients all affect phytoplankton's ability to grow, photosynthesize, and survive. We've talked a little bit about this already. Okay. All right. So how do we measure that? This is called the PI curve. I have another video for that. It's right here.